In this problem, we have two forces forming a couple. You know that because they have the same magnitudes for all the components, and for all the components, they have exactly opposite signs. Therefore, these two forces are of the same magnitude but opposite direction, and they are also separated by a distance. Therefore, they form a couple, which is a pure moment, because the two forces, they actually cancel each other out. So what remains is a pure rotational effect, and we need to determine that moment. And we're going to use this equation, the moment equals to, again, position vector cross the force vector. So because we have two force vectors, which one goes into this equation? You actually can choose either one you want, but in this case, because the problem statement gives us this force as a positive force, the other one is negative F. So for that reason, we're going to choose this force to go into this equation. So after we have made that decision, now for the position vector, it must start from the other force vector and ends along the line of action of this force vector that we've just chosen. So again, even though there are unlimited ways to draw it, so we can draw it like this or like this, however we want, as long as it starts from the other one and ends on this one. But more obvious choice will be position vector from point A to point B. So this RAB will go into our equation. So at this point, you should be very familiar with determining position vectors. So in this case, position vector RAB equals to 3i plus 2j minus 2k in the unit of meter. The force vector is given. Therefore, all we need to do is to set up our matrix to be I, J, K. Then the second row, the three components of the position vector, 3, 2, negative 2. And then the next row, three components of the force vector, because we've chosen this one. So negative 4, 3, negative 4. And then we have 2 times negative 4 minus negative 2 times 3, I minus 3 times negative 4 minus negative 2 times negative 4, j, switch back to positive, 3 times 3 minus 2 times negative 4, k. And as a result, this equals to negative 2i plus 20j plus 17k. And that is the moment vector with a unit of kilonewton meter, and its magnitude equals to simply square root of negative 2 squared plus 20 squared plus 17 squared, and that equals to 26.3 kilonewton meter. So this is the vector form, and this is the magnitude of it. So as you can see, to determine the moments of a couple using vector formulation, again, we use the same formula to calculate the moment of a force about a specified point. In this case, we choose one of the force vector in this couple to go into this equation. And as soon as we've made that decision, the position vector must start from the other force vector and end on this chosen force vector.